Hello everyone, welcome you all to Swan Analytics, turning healthcare data into real-world insights. In this session, we will solve a problem, and the problem is for every patient. Let's see how to identify the first date they received erythromycin between the study period. So this is the problem statement: how to identify the first date the patient received erythromycin between the study period, which is 2018 to 2022. Now we will solve this problem using two languages, that is R and Python. First, let us understand the logic. We'll have an overview, and then we'll move into towards the fundamentals of syntax part. So here we can see in our language we are installing the packages, and in Jupyter Notebook we also import pandas library. So there are two packages that we're installing, and then we read the data. Same thing here as well. In Python, we'll be reading the data using the pandas library. And here in R, it's dplyr package we are using. Then we convert the date value into proper format. Currently, the raw data is not in the proper format. So our first job will be, after reading the data, is to convert the fill date into a proper format. This example of data is from the OPTUM database, RX claims database. RX claim is a dataset from which you are pulling the prescription data, the date the patient filled the prescription, the number of days of supply, NDC code of the drug, and so on, generic name of the drug. So all these details will be present in the RX claims dataset in OPTUM database. So let us take an example of OPTUM database and see how we can solve this problem. Now we have converted the date into a proper format in R. Similarly, we can do the same in Python as well. You can see the approach is also very similar. If you see this approach, it's very similar. And the next logical part is selecting the drug of interest. The problem statement was taking all the patients' first date of prescription of erythromycin. So the drug is erythromycin, drug of interest. So we are filtering erythromycin here in R. Same in Python as well. Then the next part of the objective is within the study period, which is 2018 to 2022. So you can see we have taken the fill date within 2018 and 2022. Same here in Python as well. Next, we are grouping by patient ID because we have multiple records per patient. The patient may have taken erythromycin over a period of time. So we want the first record. So we are grouping by patient ID. Here as well, we are in Python as well, and R both we are grouping by patient ID. Then we are summarizing in R. Summarize the function. We are getting, so you can use the min function. Just like if you are familiar with SAS, you know that proc summary, we use proc summary, and within proc summary, we use the min max function. Here as well, it is similar. Summarize, and then we are using the min function. In Python, we are directly using the aggregate function, AGG function, and getting the minimum of the fill date. The minimum of the fill date is essential because we are looking at the first prescription of the drug. The first date the patient had erythromycin. So we'll take the minimum, the first date. If you notice in R, we dot groups equal to drop. We are using this function. We'll drop the grouping. On the other hand, in Python, it's not needed. We don't have to do that. In our language, the data frame remains grouped, while in Python, SAS, that is not the case. So SQL as well, we don't have any group. Once you have grouped already, the dataset doesn't stay that way. So in R, you have to explicitly mention to drop the groups. So it doesn't stay with the patient ID as grouping variable for any further operations on the dataset. So that is a fundamental how the overview is the logical approach of solving this problem. Now we will go into the syntax part. So first we are reading the data. This is how we are reading the data. Read.csv is how we are reading the data. The read.csv is coming from dplyr. Similarly, loop date in R we are using for manipulating the date and time. So we are updating the format of the data from character to proper data set. You can say it's year, month, day format. So the input data set is DMY format, and we are reading it in that particular format. So we are giving the input data set format here. And finally, the result is the form of year, month, and day. That is how we are doing it in R. Same here, approach it Python as well. If you see the same approach we are using here as well. The difference you see is here when you convert the date into a proper format, you're using as.date here function to convert the character date variable into a date variable. Here you're using in Python PD to date time. In Python, you have to explicitly mention the library also, pandas library. So this particular function is coming from the pandas library to date time. So we have to explicitly mention that PD to date time. In R, we don't mention the library name from which this particular function is coming. And that is why you see its pandas library is explicitly mentioned in Python, but not in R. Then the other difference you see is here we are putting in square brackets the fill date. So the data set and the column. The column is given in quotation inside the square brackets. On the other hand, you are using a dollar sign in R. RS claims dollar fill date. So data set, and within the data set, the variable name is fill dt. That is how the approach changes. And the same approach changes here as well. Here as well, you can see it's which variable you are formatting. It's fill dt from Rx claims. In R, in Python as well, you can see it's a fill dt that you're formatting. So you're giving within square brackets inside quotations. That's a minor difference here. Now coming to creating index date. Next we are getting index date. And in index date, we are giving the input data set as Rx claims. The pipe operator means pass it on to the next step. And then you're filtering, and which is generic name is erythromycin. And you're converting into uppercase just in case some of the values may be in lowercase. If there are any lack of uniformity in the case of the values within the generic name column, we want to make sure it is all uppercase when we are giving the filtration criteria. Same in Python as well. So you can see we are ensuring that the difference is the method is given after the dataset name, column name, and the method that you are applying here. It's not upper, the string function, and you're converting into uppercase and giving the condition erythromycin. The value is erythromycin. And here the next is you're looking at the fill date within a specific interval, that is 2018 to 2022. Within this 4 years span of time, you're looking at the study period. So you're looking all the patients who've taken erythromycin within this period. And every time you check the convert into date value, otherwise it will be treated as a character. So in order to convert into date, you're using as.date. And that is coming from loop-read library. Here as well, that is in R. Similarly, in Python, we are using the same filtration criteria with the dataset name and within bracket column name within quotation and the same condition of study period. And then we are grouping by patient ID because there are multiple records per patient and we want to pull the first record. And as index equal to as false in the Python. So if we are giving this condition so that patient ID is not treated as a index variable, that is not necessary here. You can see the result. 0 is the index for patient ID. 1 is the next index, so on. So in Python, it starts with 0. In R, it starts with 1. In Python, it starts with 0. In SAS, we have it's similar to OBS. If you do a proc print using OBS, you might notice the numbering that comes 1, 2, 3, 4, 5. So that can be considered, that is equivalent to the index in Python. So we don't want to treat the patient ID column as an index. That is why we are giving treated as false. It's not needed for us. Now, there are scenarios where it might be needed, where you want to really subset based on the index value, subset or filter based on the index value. That is not the case here. We are not really interested in that in this particular scenario. And then you are taking the aggregate in Python. So you're taking the minimum value aggregate. It's similar to the like prop means we are using. It's aggregate here, and all this min is aggregate function. The minimum value out of multiple records, aggregator of records. So this min function you are applying within the aggregate, and for which column? Fill date. That's how we can generate the results. You can see we got the minimum value for all the patient IDs. So patient ID 1 index date is 15th of June, my first value, and so on for the remaining patient IDs. Let me run in R. I will not run it again. I have already installed the packages. I don't want to reinstall it. So I'll just run the rest of the code excluding the installation packages. In R, if once we install the package, we don't have to reinstall every time. So this is the same results we are getting through Python as well. R and Python, they're giving the same results. So that is all for this session. Yes, help you understand the concept. Please like and subscribe. If you're preparing for roles in clinical data analytics or real world evidence, RWE, RWD, I also run practical sessions focused on real industry workflows. And in the next video, we will build on this further. Thank you very much.